Okay, now we're going to look at perimeters of similar figures. The thing that you need to know here is, and this is one of your theorems, that the scale factor is going to be the same as the ratio of the perimeters. So you can use that to find perimeters for different figures. In this case, for the first part of this, we need to find the scale factor of the new pool to an Olympic pool. So if we look carefully, what we want to do is compare the corresponding sides. It says we have a length of 50, a width of 25 meters for an Olympic-sized pool. The new pool will be similar in shape, but the length will only be 40 meters. So if we're comparing a new pool to an Olympic pool, then the new pool has a length of 40, and the Olympic pool has a length of 50. So our scale factor in this case, I'm just going to use SF for now, is equal to 4 to 5. For the second part of this, we want to find the perimeter of an Olympic pool to a new pool. So we know again that the length was 50 meters and the width was 25 meters for the Olympic pool. We know the length for the new pool was 40 meters, but we don't know the width. And in this case, we don't need to know the width. So what we do is we take the perimeter of the Olympic pool, which is 2 times 50 plus 2 times 25. This gives us 100 plus 50. So the perimeter of the new pool, or I'm sorry, the Olympic pool is 150 meters. And what we can do is take the scale factor, which is 4/5, and then compare that to x over 150, where this is the perimeter of the new pool and this is the perimeter of the Olympic pool. We do our cross multiplication. We would get 5x on one side, and on the other side we do 4 times 150. And again, I'm going to do it this way because I don't have a calculator in front of me, and it's just easier without a calculator to do it this way. If we divide both sides by 5, we get x here, and over here I can divide top and bottom by 5. We get 1 here, we get 30 here. That tells us the perimeter for the new pool is going to be 120 meters. So again, for the first part, we do scale factor will be the ratio of the lengths. So in this case, it's 40 to 50, so the scale factor is 4 to 5. Then we take the perimeter of the Olympic pool, which is 150 meters, and again, using that theorem 6.1, we can use that to find the perimeter of the new pool. So it's x over 150 equals 4 over 5. We cross multiply. We get x equals 120. So the new pool has a perimeter of 120 meters. For this next one, we want to find the scale factor. Again, just take two sides that are corresponding, and again, it's FG, HJK. So this is the bigger figure to the smaller figure right here. And so what we do is we say we can take any side. I'm going to do FG over AB, where FG is 15 and AB is 10. If we divide both sides by 5, we get 3 over 2. So our scale factor is 3 over 2. So for the second part, we want to find the value of x. Again, we can use the scale factor here, so we say 3 over 2, and then we look at the two parts that correspond here. The big one's 18, the small one is x, so we say 18 over x. We're going to cross multiply. We get 3x equals 18 times 2. I'm going to leave it like that because I can actually simplify without a calculator. 18 divided by 3 gives me 1 here and 6 here, so x is equal to 12. We get x equals 12. Third part of this, we want to do our perimeters. We can find the perimeter of the first one by doing, I'm sorry, the second one by saying 15 plus 9 plus 12 plus 15 plus 18. We know 15 and 15 is 30. We know 18 and 12 is also 30. So that's 60. So altogether we have 69. And we're going to use our scale factor one more time. We can write 3 over 2 equals 69 over x. We don't even need to know what the other sides are. I'm going to have 3x is equal to 69 times 2. I'm going to divide both sides by 3 here. We get x, let's see, dividing both of these, we would get 23 here. So 23 times 2 gives us 46. So the perimeter should be 46. There we go. And we're all set. Thank you.